The first question from exercise 3.2 of matrices is this, which says let A is some matrix, B is some other matrix and C is another matrix. Find each of the following. There are various parts in this particular question. First we have to find A plus B, then we'll be finding other things as well. Let's discuss this part first. What does this part say? For A, B and C given, how do we find A plus B? The matrices A and B can be added together if they have the same order. For adding or subtracting two matrices, their order must be same. That is very important. For adding two matrices, the order should be same. Order of A is 2 by 2. Order of B is also 2 by 2. And therefore, yes, they can be added together. Now, how do we add them together? We add them together by adding the corresponding elements. The corresponding elements means this A11 and this B11 get added together. A12, B12 get added together. A21 and B21, A21 and B21 get added together. And similarly, A22, B22 get added together. So, the matrix A plus B, the matrix A plus B would be equal to what? This can be written as A is 2, 4, 3, 2 first of all, and B, the matrix B, as you can observe, is 1, 3, minus 2, 5. This is matrix B, right? Addition of these two matrices is very simple. What we'll do is we'll add the corresponding elements, which is 2 plus 1 over here, 4 plus 3 over here, 3 minus 2 over here, and 2 plus 5 over here. This is how you add the two matrices. This is 3, 7, 1 and 7 over here. This is what you have. That's the sum of A and B, as you can observe, right? This is the first part of this question. For the same question, let us take a look at part 2. Find A minus B. Now, how do we find A minus B? The process is similar to finding A plus B. First of all, the order should be same, and as we know that the orders are same only over here. A minus B, let's write the two matrices first. A is 2, 4, 3, 2 and minus B is 1, 3, minus 2, 5. Right? This is what we have. These are the two matrices. Subtracting would be possible by subtracting the corresponding elements. 2 minus 1, this is what I get. 4 minus 3 is what I get over here. 3 minus minus 2 is what I get over here. 2 minus 5 is what I'll get over here. This is the matrix. This is the difference of A and B. This is A minus B. What is this further simplifying into? This is 1. 4 minus 3 is 1. 3 minus or minus 2, 3 plus 2, which is 5. 2 minus 5, which is minus 3. And yes, this is my answer for A minus B, as you can see over here. Next, let's take a look at this part, the third part. What does the third part say? This is 3A minus C. For A, B and C given, we have to find 3A minus C. Now, what does 3A imply? First of all, 3A has to be found. Now, 3A is obtained by multiplying each element of the matrix A, each element of this matrix by this scalar quantity 3. That's what we are supposed to do. So, 3A minus C, this is third part. 3A minus C, let's write it properly. This is 3 times matrix A. What is matrix A? 2, 4, 3, 2. Minus matrix C. C is that matrix over here. This is minus 2, 5, 3, 4. This is the matrix, right? So first we'll simplify this and then we'll subtract this one. How do we simplify this? This scalar quantity gets multiplied with each of the elements present in the matrix. This 3 gets multiplied with 2, this becomes 6. 3 gets multiplied with 4, this becomes 12. 3 times 3 is 9. 3 times 2 is 6. I hope that's clear. Yes, that's pretty simple. And then we have minus 2, 5, 3, 4, which is further equal to, which implies 3A minus C is equal to 6 minus minus 2. Right? Let's subtract the corresponding elements. 12 minus 5 is what you'll obtain over here. 9 minus 3. 6 minus 4. This gets simplified to what? 6 minus or minus 2? 6 plus 2, which is 8. 12 minus 5 is 7. 9 minus 3 is 6. 6 minus 4 is 2. And yes, this is my answer for this third part, 3A minus C over here. Right? Let's take a look at this fourth part. What are we asked? We are supposed to find the product AB. Now the product AB can be obtained easily if the product exists first of all, and when can you find the product? For product of two matrices A and B having order M by N and P by Q, this and this should be equal. That is, N should be equal to P. This is a row by column multiplication, and yes, the number of columns in this should be equal to the number of rows in this, and then the product that obtains C will have order M by Q. The product will have order M by Q, this and this over here. This will be the final order of the product, right? And N and P should be equal. That's the important condition. Here, as you may observe, both the matrices are having A and B, both are having order 2 by 2. So yes, 2 and 2 are equal. That's something which is required, and the final order of the product would be 2 by 2, as you can observe from the outside numbers. The product AB, let's take a look at the product AB. How do we find the product AB? Let's write this 2, 4, 3, 2 multiplied with 1, 3 minus 2, 5. We study row by column multiplication, and row by column multiplication implies that the first row gets multiplied with first column to give us the first element of the product. This element, the first row and second element, the column present in the first row and second column is obtained by multiplying the first row with the second column, right, and adding the corresponding terms. So let's do it. This is first row, first column. We get this one, 2 times 1 plus 4 times minus 2. This is what you have. Then this element, the first row, second column, 2 times 3 plus 4 times 5 is what you get over here. Right. Next, this one, second row, first column is what you do. 3 times 1 plus 2 times minus 2. This is the product that we obtain. Then 3, 2 gets multiplied with this 3, 5, which is 3 times 3 plus 2 times 5. This is the product of the matrices A and B. This is the product of the matrices A and B, which implies, let's simplify this further, AB, the product AB is equal to what? This is 2 minus 8. This is 6 plus 20. This is 3 minus 4. What about this? This is 9 plus 10. And let's simplify this. One more step remains. Let's simplify this further. This is minus 6. This is 26. This is minus 1, and this is 19. That is the answer for this part over here. Fourth part, the product AB is being asked over here, right? Let's take a look at this over here. Fifth part, BA. How do we find BA? Process once again is very simple, very easy. Let's multiply B and A. This time B will come in the front. We have 1, 3 minus 2, 5 gets multiplied with 2, 4, 3, 2. This matrix over here. The product can be obtained by multiplying this row with this column for the first element. First row, second column, second row, first column, and second row, second column. That's what you are supposed to do. Let's multiply the first row, first column to obtain this element. 1 times 2 plus 3 times 3. Then we multiply the first row and the second column. We get 1 times 4 plus 3 times 2. Let's multiply second row, second column. Minus 2 times 2. Okay. This is minus 2 times 2 plus 5 times 3. And here what you get is second row, second column, which is minus 2 times 4 plus 5 times 2. This is what you get, right? Observe this carefully and then it is pretty easy to solve. This is 9 plus 2, 11. This is 4 plus 6, 10. This is 15 minus 4, 11. This is 10 minus 8, which is 2. And yes, that is my correct answer for this product, BA over here. You take a look at this complete thing. Okay, is that all? Yes, that is all in this question.